We're starting back on section 4.4 and we're trying to do example 3. Again, is one of the examples that we're comparing first derivative and second derivative test to find the local extrema. What I try first is the first derivative test. So let's take the derivative of this, and what do I get is the derivative of the first one, which is 4x to the power 3 times the second one unchanged, then plus the derivative of the second one, which is 3x squared x minus 1 to power 2 times derivative of inside, which is 1, then times x to the fourth. And I'm putting the 3 in front, and x to the fourth, x minus 1 to power 2. For either of the tests, I will need critical numbers. So let's try to find the critical numbers. And how do I do that? I factor. Common factor between x to the power 3 and x to the power 2 is x to the power 3. Between these two is x minus 1 to power 2. What is left out of the first one is 4 times x minus 1. What is left of the second one is 3x. So the entire thing becomes x to the third, x minus 1 to power 2, 4x minus 4 plus 3x, 7x minus 4. Now, I have how many critical numbers? X equal to 0, this one x equal to 1, this one x equal to 4 over 7. Now that I have all the critical numbers, let's do the first derivative test. First derivative test. And so how do we do that? You draw the number line, you put in all the critical numbers in the order that they go. 4 over 7 is less than 1, bigger than 0. It goes over here. You're evaluating f prime. You finding the signs for f prime. Let's see. The f prime is this, right? And then f prime is a polynomial of degree 6, and the leading coefficient is 7. 7 times, and so 7x to the power 6. 7 in polynomial of order 6 with a positive coefficient is going to have n behavior that's positive on both sides. So I know that positive here, positive here. Then I look at, again, you very obviously can use other information like test points in each interval and so on and so forth, but it's not the best use of your time. And so what I do is I just use the information about the polynomial to decide about the sign as much as I can. Sometimes you use test point because it gets too much information. Now over here I see that x equal to 0 is a root of order 3. Therefore, when I pass x equal to 0, the sign has to change. It becomes negative. I see that 7x minus 4, which gives you a root x equal to 4/7, is a root of degree, this one, 4/7 is a root of degree 1 because this linear factor is of degree 1. And so I'm going to put in degree 1 is in odd degree, so the sign has to change. Now x minus 2 is of order 2, and sign even orders, the sign does not change, and it didn't change over here. What is left is to find the increasing decreasing. Here f, not f prime, is increasing, f is decreasing, f is increasing, f is increasing. I see one top of the hill, that's a local max, and I see a local min, and this one is neither. And so what is the local max? Local max at x equal to 0, and that gives me, now it's the time that I need to go back and plug it back into the original. If I plug it back into the original, I get y equal to 0. So 0 and 0 is the local max. And the local min, is going to be at x equal to 4/7. I have to plug it back into what I have to find the y value. Y is 4/7 to power 4 times 4/7 minus 1 to power 3. And the value of that is going to be negative 0.0083 approximately. And so that's the point and 4.7 and approximately negative 0.0084. This is there's an exact value for that, but it's just long, and so we're gonna ignore the rest of the decimals. And so this is the local min and local max. And now let's talk about how do we do with the second derivative test. With second derivative test, what we need to do is to find the second derivative of the function. And here is, let's say, with the similar process that we did before, we found the second derivative of the function and we factored it. In here, what we need to do is to figure out what is f double prime at the first critical number, so that the part in finding the critical number is the same for both. And so I have to figure out f double prime of 0, which if I plug in here, I get 0. So that is not helpful. It's going to say inconclusive. Then I have to find f double prime of 4/5. And then I have to find f double prime of 1. F double prime of 1 is going to be, again, 0. It's going to be inconclusive. I know that the first one, at x equal to 0, there is a local max. So the second derivative test did not detect this. So that's the shortcoming of second derivative test. But also over here, I know that at x equal to 1, we have neither, but I can't decide what it is. Again, another shortcoming. So it can be inconclusive, and one of them can be a local max, and one of them can be neither. So what is remaining is to evaluate f double prime of 4, which we did in a little bit, and it turns out to be 0.24, and that's bigger than 0, so you get a local min. So for some values, it was it actually determined what it was, if they were local min or local max, and then for some values it didn't, and then for some values that they weren't, it didn't detect either one either. So it's kind of there are a little bit of unknown when you're doing second derivative tests. And now let's see, if you graph the function, this is the original that we graphed over here, x to the 4th times x minus 1 to the power 3. You see that there's a local maximum at x equal to 0, but it has an f double prime also is 0 in there, and f triple prime is going to be 0 there, and so that's the issue that we're having. It's just not going to give me any information with the second derivative test, but first derivative test, it was fine. Over here we have this point that f prime is 0, but f double prime is bigger than 0, and so that one gives me a local minimum. And then for this point, it was a critical number. F prime at 1 was 0, but f double prime was 0 also, and it turned out it's neither of the local extremums. Okay, so now I want to discuss the differences that we observed. Second derivative test does not require a table or number line to find the local extrema. Sometimes this is a good thing for us because it's much easier not to put test points in, evaluate things, just find the second derivative and plug in there instead of a lot of test points and other things. And so if f prime of c is equal to f double prime of c equal to 0, then second derivative test is inconclusive. So first derivative test can be used only. In this case, f may or may not have a local maximum extremum at c. So it may or may not. That's important to remember. Inconclusive means I don't know. It could have it, it could not have it. When you have the choice, you use the second derivative test when finding f double prime is not too complicated. So one thing is that if f double prime is too complicated, don't use it. Then first derivative test requires a table, number line for values of f prime. Remember that when you're doing first derivative test, you're finding the sign for f prime. To find the shape of the graph, you may need to use both first derivative and second derivative, even if it's not necessary. It is recommended to do so to check your work and